All right, everyone, we are back and we are going to talk about yielding criterion. So far we have been in the elastic regime, but finally we're getting into the plastic regime. And we've already discussed essentially our yield strength, and we can see that on our stress strain curve. But there are different yielding criteria, and they've been developed over time to predict when materials will fail and yield. And sometimes it's not as simple as when we're loading uniaxially. So the first attempt at developing a yield criterion was made by Rankine. And Rankine was looking at, okay, well, even if I have a complex stress state, my maximum normal stress will be when my material yields or fails. So the simple criteria was sigma 1 is greater than my yield strength, then it's going to yield. So this worked well, and it worked well for basically very brittle materials, ceramic materials, things that will fail under maximum normal stress. However, it didn't work so well for metallic materials and other materials that yield when there's larger shear stresses because, again, this criteria ignores shear stresses. So Tresca developed another criteria. Well, looking at, okay, well, that's going to be our maximum shear stress criteria, and it was described as sigma 1 minus sigma 3. And if we look at our Mohr circle, if I have a complex stress state like this, sigma 1, sigma 2, sigma 3, and I look at 3 more circles, my sigma 1 minus sigma 3 is going to give me the maximum, basically shear stress in any complex stress state. So, again, we'll stay away from that. But effectively, that's what we're looking at here, technically divided by 2. But anyways, you get the picture. And this worked very, very well, again, for lots of metallic materials until in 1913, where World War I and World War II subs were failing at stresses that were lower than this prediction for Tresca. So von Mises criteria looks at shear deformation energy criteria. So effectively looking at the contribution of the shear deformation energy for all of essentially the stresses that exist in a system. So, and you could actually rewrite it in terms of purely principal stresses, and we get the Tresca criteria here. So these are 3 different criteria, and they need to be utilized in an appropriate setting. So if you have something that fails primarily from normal stress, you can use Rankine, Tresca, or von Mises, but it is really important because you can see this is von Mises, this is Rankine, and then the green is Tresca. You can see that here in von Mises, if I'm not outside of this region, I am not going to fail. But if I were to go by my Rankine or even my Tresca criteria, it would fail. So you have to be cautious and somewhat conservative in terms of where you think your material will fail or not, and just be careful when you don't choose just arbitrarily. And this happens a lot when you run FEM analysis and especially in SolidWorks. So just be cautious of that system. All right. So next time we're going to get into yielding mechanisms, and we'll see you in the next video. Thanks. Bye.